you all. Thank you.
Now I welcome to Dr. Sirisha Madam to introduce the Professor KVS Sarma garu.
Thank you, sir. It gives me an immense pleasure to introduce today's resource person, Dr. KVS Sarma garu. He pursued his doctoral studies in statistics from SV University and also trained in statistical quality control and operations research from the unit of Indian Statistical Institute at Madras. He retired as a professor in 2016 from Sri Venkateswara University, Tirupati, but his zeal to learn and enhance his skill set drove him to become a biostatistician and research coordinator at Sri Venkateswara Institute of Medical Sciences, in short, SWIMS, Tirupati, from 2017 to 2019. At present, he is a statistics consultant to SWIMS, Tirupati. He offers a range of areas for consultation in various categories such as individual researchers, faculty, and institutional level. His areas of interest mainly count on statistical methods in biology and medicine, inventory modeling, statistical quality control, data analysis and interpretation, multivariate statistical analysis. Sir has a commendable span of 41 years of research experience. To his credit, 8 MPhil and 20 PhD degrees were awarded and 62 research papers were published in reputed national and international journals. He has also authored and co-authored 6 books. Here are a few to mention. Statistics Made Simple, Do It Yourself on PC, published by Prentice Hall India in 2000. The other book is Multivariate Statistics Made Simple, A Practical Approach, published by CRC Press, owned by Taylor and Francis Group in 2018, jointly with R. Vishnuvardhan Garu. Sir, your journey of life has been an example of the thirst of attaining knowledge and a model for upskilling aspirants. It's a pleasure to have you among us, sir. Thank you one and all. And now, with due respect, may I now invite Professor Sarma garu to deliver the talk.
Thank you. Am I audible to all of you? Are you able to hear me?
Yes, sir. Yes, sir. Yes, sir.
Yes,
Very
sir.
good. So I am first of all happy to be a resource person for this program organized by GITAM University, which is well known across the globe. And Dr. Sridhar was formerly a fraternity to the Department of Operations Research, which made me a teacher. I became a teacher of statistics in the Department of Operations Research. Even though today I'm preferring to talk on sample size determination, all these things were basic questions to me way back in 1977 when I joined as a teacher in the Department of Operations Research. Everything was a question. I had to teach so many things to students. I didn't know many things. The gap is to be filled, and the students were also very, very enterprising. And it was not a teacher-student relationship at that time, I remember. It was more like a friendly discussion. Even if I failed to explain a concept, some of the students used to come to me, say, yesterday I found this in so-and-so book. Will it match with what I say, or will it help us? Then I was seeing another teacher in that man. My total journey since 77 to 2016 was like this. I never claimed that I have done anything very extraordinary, but there was a thirst in me. That thirst is, I must be a more practical person, not leaving the theory. I must learn theory. I must be able to address the issues raised by my community regarding statistics. If somebody says that I'm a statistics teacher, if I am unable to answer some of the questions, then it's not wrong. I must learn and answer, just like what Tirupati Rao was telling. That is the correct way I think most teachers would do. But when it came to answering questions raised by non-students, questions of students are different. Questions in the society are different. Questions in the society, I mean, for me, non-statistics society. These questions are different. They expect answers which are very short, which are immediately usable, and so on. My journey started like this. I was working in operations research. Inventory control and management was my research area. It went on like that. Later, A transition from Karnool took me and landed at Tirupati in Statistics Department, where I had to address quality control. Even though I was trained in quality control and ISI, I got an opportunity to teach here now. All these things went like this since I retired, and I consider myself as a learner always. I will spend these few minutes before I go to this. Why I'm telling is, I don't know the heterogeneity among the listeners of this webinar. I understand it's a heterogeneous containing students and faculty from different areas. As teachers, some of you who are sitting, you know that it is difficult to teach statistics to different communities in a single platform. If you have to explain statistics to commerce people, they don't like medical examples. Students of engineers from industry, they don't like commerce examples. So usually statistics by its very nature is a mathematical subject, but it has specific applications to different segments like society, medicine, area, community health, industry, manufacturing, marketing. So everywhere, the listener expects that his problems will be solved with statistics. So this talk, which I am going to present or spend some time with you, may not be able to reach everyone in its real spirit, but I will try my level best to reach them with one focus. This, my topic actually goes to, I will be talking to you and also shifting to this one. And this is what I am actually, yes. Is it visible, my screen?
Share outundi, sir.
Yeah, good. I thought this is the topic I have selected for today's talk. I'll spend a few minutes on this and then come back to you. Sample size determination in research and some of the practical considerations I wanted to share with you. I shall try to be very brief in view of the time allocated for this one. In research, we always try to find out something which was not known to us earlier. That is the purpose of research. If I know everything, there is no need for research. If I know everything, there is no need. If I don't know, I have to research and then find out. Therefore, I will conduct a study, an examination, an assessment, a survey. All these things lead to search. Today, people talk about the present lockdown, pandemic situation, the people's lifestyle, finances, and all these things. Every day government will be releasing certain findings. ICMR tells something, WHO something, and all these things are results of research. Undoubtedly, everything is a research. Now the question before us is how to go about. There is a common principle or the common, what I say, it's not a principle virtually, a common custom people follow. Do a research by observing a situation. What do we mean by observing a situation? If somebody asks me, is there anyone moving on the road nearby my house? There are two ways. One is go to the road and examine on the road. If you don't find anyone, say that there is nobody on the road. That is one method. The second method is you are not allowed to go into the road, but you wish to know whether anyone is going there or not. Several methods. One, try to listen. Is there any scooter going on that way? That gives an estimate. Try to listen whether any footsteps are heard. That also gives an idea of whether somebody is there. You see how research goes. The second one, what I said, is what in statistics we call as estimation. We wish to estimate. When I don't know the real truth, I at least believe on what is called the estimate. How many people are sleeping, or how many people are there in a particular quarantine ward in Tirupati? That is my question I wanted to know. Answer is very simple. You identify which quarantine ward, you contact them, you get the number, the ends the matter. The other is you don't have all these access. Now ask your friend, ask somebody, and try to get, ultimately ask a news reporter, he will tell correctly. So in all these things, we'll be interested in doing research by conducting a survey. In doing a survey, the problem is, shall I survey the entire thing or shall I survey a part of that? Why don't you do the entire thing? It is costly, it is time consuming, it is also not possible in many times. Oh, then you go for a sample. Okay. When do we go for survey? 100% survey. We call it as a census. Census, C-E-N-S-U-S, census. There are about 210 members in the hospital on beds. In my hospital, there are 210 patients sleeping. Every day, the hospital sends a census at 8:30 in the night. At 8:30, they collect what is called hospital bed census. Go each and every patient with his ID, we must state whether the patient is in or out. In means on bed, out means discharged. Discharged alive, discharged dead. All these things must be reported. The question of sampling doesn't arise. Sir, I will just examine 10 beds and tell the answer. No. Similarly, so there you have to go for 100% inspection. Similarly, when you go for evaluating the answer scripts of about 50 students in a class, you don't do sampling. People will find fault with you. You have to evaluate each and every script. Therefore, census is a must there. But if you want to know how much glucose is contained in your body, a sample is enough. Don't take 5 liters of blood into a bucket and take it to the hospital, calculate what is the glucose, and try to put it back if you are still alive. This is a bad example where census is not meaningful and we go for only sample. Now, the question is, how sample must be taken? What must be the size? There is a common feeling among people that 10% or 12% of the target group can be a sample. In medical community, people say, sir, we'll take 30 people in this group, 30 people in this group, or totally 35, 40. These are all unscientific methods of determining the sample size. We may have to remember that by reading a sample, you are omitting a lot. That is very important. By reading a sample, you are not reading many things. Therefore, the conclusion which we are giving must be valid not only for what we have investigated, but also for what is not investigated. That is where many people need a statistician's help in identifying the sample size. I will try to take you to this one I told. This is how we broadly divide surveys. Why do we conduct a survey? To understand a population characteristic. Yes, I don't know what is happening, for example, present COVID. What is the psychological behavior of elderly people during lockdown? I don't know. I have to do a study. Estimating the unknown features. How much they spend on food items outside during lockdown. You have to estimate. What is the quality of life? What is the happiness index? You have to estimate. I may have to compare 2 or more populations. I wish to compare the happiness in Andhra Pradesh with that of Telangana by conducting a survey. That is a population, this is a I also wish to study what is the patterns of time. What is the spending pattern of students in a deemed university when compared to spending pattern of a classical university? I wish to collect data and examine during the last 5 or 6 years from different communities in the college. Yes, that needs a survey. And sometimes we conduct experiments, laboratory experiments, human experiments, sometimes called clinical trials. We give an intervention. For example, we give a new type of mask, we give a new tablet, or we give a new method of learning. For example, everyone is nowadays adjusted to teach or listen from Zoom. It was not there maybe about a year ago. It was a limited activity. I wish to know what is the response to this one. And in some other cases, a little bit advanced but very popular, we wish to conduct a survey to do what is a predictive model. I wish to predict the behavior of people, vehicles, market, trends, and all these things. Then also I need a survey. In all these things, we divide the study something like this. One is called a descriptive study. A study can be purely to describe a population. This is like this, this is like this, this is like this, that's all. So we call it descriptive or observational study. We are not interested in verifying whether something is true or not. No, we simply describe. Second thing is comparative studies. We wish to compare whether the situation in one group is better than the situation in the other group. What is the default rate of loans? People take loans and don't pay it to the bank. I wish to know what is the rate of missing, defaulters in the bank. What is the rate compared to two different districts in Andhra Pradesh, two different states in country, something like that. There, the objective is to describe the population using some parameters. Kindly remember that every study needs an outcome in terms of what is called parameters, say default rate or quality of life. This can be done either by a census or a sample. In comparative studies, what we try to do is we compare the populations, we identify the better one, that will be the objective one, whether inhaler is better or a tablet is better. Then also we have to do a census, sample or standard of design. So this is by type, whether it is because in the coming few minutes we may have to answer these questions to the client. We must first ask the client, is your study a descriptive study or comparative study? Sometimes it can be a mixture of both also, but usually it will not be like that. And sometimes we divide the study based on what's called timeline. Timeline in the sense, data will be obtained during a fixed time period, like a day, a week, a month, or a period of 6 months. We call it as cross-sectional study. All the data, the references, the description is applicable only for the period ending from May to June, let us say. The other one is a longitudinal study where we do what is called a follow-up. We do an initial study. After 3 months, we observe whether there is any improvement. Another 3 months, we again observe. It is called longitudinal studies. And there is another way we capture. We have to answer all these things before we take up a practical project. How do you capture the data? Are you doing from tomorrow onwards? That's called prospective. Or are you collecting data from existing records, retrospective records? I will collect all the information about the patients from a hospital during the last 2 years. I will collect all the files and then collect the data. We call it retrospective study. These issues become very pertinent even in non-medical research. We'll try to see the outcomes. In any research, what are the outcomes will become important. They call it outcomes in medicine, and in social sciences, we simply call it variables, but a better word is outcome. If you are doing a study, what is the outcome? These outcomes are things which have been observed on the subjects, whether it is a human being, animal, a machine, a computer, a toner, a laptop. What is that you are observing? You are observing a categorical characteristic sometimes. Categorical means discrete. One example will be like yes or no, whether it is functioning or not functioning. There you have two options on this. Yes, green, into is, this is a binary choice, yes or no. You may have different levels, green, orange, dark orange, still dark orange, indicating something like low, moderate, high, very high, something like that. And in all these cases, our interest will be data will be summarized. Data will be measured like this, observed like this, not measured. And it will be summarized as number of cases. We call it as count. How many people were tested positive yesterday in Andhra Pradesh for COVID? How many tests were conducted? How many people died in the hospital? You see, how many? How many? Many means count. How many? It's the word itself says that you have to count. There is nothing like a measurement. We call this as categorical characteristics. And in mathematics and statistics, we call such variables as qualitative variables or discrete variables, more apt. The other one is another type of outcome, which is not observed, it is measured. It is measured. It is a continuous one, like how many kilometers traveled. What is the weight loss in the body? What is the body temperature? If you go to a mall or a cinema hall, in this COVID situation, or to any business center, the gentleman comes with a thermal scanner and says on your head, say this is the temperature, but he will use this red or green because there will be an identification that whether it is a green, orange, red, you will be done. Or if it is temperature, you say that's 98.5, 99 point something, that's a measured one. Such data which is measured mathematically, it has the property that it allows fractional values, whereas categorical variables will not allow fractional values. They will be always discrete. They may have some fractional values, but always in jumps. It is something like any value between A and B is not meaningful there. So it is like measuring using a device. It is measuring the weight, and all such variables will be summarized. The problem with practitioners will be they collect a lot of data, but they approach a statistician because they don't know how to summarize. That is the headache. They are summarized as mean and standard deviation, very popularly used summary statistics. There are other things called median and interquartile region. A statistician can help other people on this aspect. So right now we assume that mean means average. What is the average distance? I have a good friend who is a medical representative. I wish to know how many kilometers he will travel every day. Oh, every day he was changing his distance. So I wish to know last month, what is the average kilometers traveled? Fine, I am able to summarize that one, mean. But very important is standard deviation. The most difficult concept people, non-statisticians face is standard deviation, because it can't be directly understood easily like mean. What is the average marks you got? I can understand. What is the standard deviation of marks? People may not immediately respond. So we must tell them that standard deviation measures the variation inside. Is it all attempts are similar, or you have very wide variations? Why do we need? We'll come to that one. So categorical variables are expressed as percentage or proportion, or we call prevalence. Measured are expressed as continuous variables which have mean and standard deviation. I told already, census, all these things can be done with census, but it has several difficulties. It is unavoidable, it is not meaningful, costly. Fatigue is there. Very important thing is fatigue. If you give about 100 questions to each investigator, ask him to go to village, get them all, he will not be happy to do it. Just like many teachers find it difficult to answer 100 student answer scripts a day. They do only 25 to 30, because beyond a number, we get what is called fatigue, and we land into errors which cannot be explained at all. So we call it as uncontrollable errors, non-sampling errors we call, and the estimates resulting out of them, we don't call it estimate. In fact, it's an outcome. They don't have meaning at all. In case of sample, you save money, you save time, and sample can be made unbiased. Unbiased, on an average, it gives like this. Fatigue can be reduced, and estimates can be provided with a desired precision. Young friends will be talking like this. Are you, some X will ask, are you coming tomorrow to that marketing place? Yes. Then he says, are you sure? 200%, he says. There is nothing like a 200%. Are you sure? He asked me, he is indirectly questioning on what is called precision. Are you precise? Or somebody says, how much you, at what time you take dinner? I will ask a student, sir, 8 o'clock. I will ask, are you sure? Yesterday, at what time you did? Sir, yesterday there was some problem. I did it at 8:30. So you are not very precise in saying that you will eat at 8 o'clock. So I will provide an estimate with some precision saying that, sir, 10 minutes this side or that side around 8 o'clock. I salute that person rather than a person who says that he will take dinner only at 8 o'clock. That is wrong. It is what is called law of variation. Every human being, every instrument, even landing on the moon, is subject to variation. These variations cause lack of precision, and we need, you may have less precision, but calculate and tell me how much precision you are able to provide, rather than telling that you are 100% correct. So my vote is not for census, but many times for sample where it is meaningful. And in a survey, we need primary question. What is your primary and secondary objectives? What for you are doing a study? If you are a statistician and somebody comes and asks you for a help, don't immediately run to the computer to solve his problem. First ask him why he is doing this survey. What is his primary objective and what are the other objectives he has? Is it a descriptive study? Let us clear from him. Is that a follow-up study? You wish to know what is the impact of this? Have knowledge on anticipation. Do you know how the results are likely to come? Do you need a pilot study? Yes. You do a pilot study, get some information, and that will help you to improve your study. Similarly, you ask what are the outcomes you are doing. Sir, I am measuring this, so many things. Good. Do you have clarity on what are categorical, what are continuous? Usually what happens is, for every person, I wish to record the age. Some people will not tell the age. Shall I leave it as a blind? At least I will try to identify what is the age group. If age is not there, I will try to put between 20 and 30, something like that. That is also a difficulty, but that age becomes categorical. Usually age is treated as continuous. Similarly, body mass index, body mass, how fatty you are. So either you try to get the information in terms of height, weight, and all these things. If it is not there, you say that underweight, weight, hefty, and obese. So categorical or continuous. Do you know what is the population where you have to collect the data? Yes, sir, I know. I have to collect it from Chittoor district in a particular mandal. Good. And what is the type of people from which you want to get? Rural women suffering from this disease. Wonderful. This clarity must be there. You can't say that every population is for every study. How to select them? Are you going to pick up all at a time? You go to the village. If you want about 50 members, identify all the 50 members, ask them come to a school classroom, get all the information. This is one method. No, sir. These people will be coming to the primary health center or Tirupati hospital. Mostly every week one person will be coming. Oh, these subjects are coming consecutively over a period. This is a very practical issue. This differs a lot from what we teach in the classroom. When we talk, we start writing that let capital N be the population size and small n be the sample size. Let us collect sample and let x1, x2, xn be the value. That is the gap between theory and practice. Well, now the objective is to describe, we have already discussed. How do you describe? I wish to estimate a proportion. For instance, like what is the percentage of beneficiaries out of a scheme? There is a scheme introduced by government. What percentage of people get real benefit? We call prevalence of a disease. How many people nowadays suffer from COVID? Estimating the quality of life. This is how we try to do. Then comes the question. You told me everything about my study. Now I wish to know what must be the size. Shall I take a very small sample? Yes. Then it will save money, but your results will be less precise. If it is a large sample, you will get good results, but it is expensive, time consuming, and may not improve if you take still further sample. Up to one level, the precision will increase. After that, even if you take more, the precision will be stable. Any sampling book will give this. And non-sampling errors will also increase when you take more in. For instance, when 50 animals or human beings or 50 machines are enough for testing, you ask for 200 machines for testing. I want to compare the toner filling in my what is called this printer, HP printer. There are two methods of filling the toner when it is empty. Method 1, method 2. My statistical theory says that you can test 10 here and 12 there. 10 plus 12, 22. But you said that I will take about 40. You will be unnecessarily wasting because you don't improve the precision. Now, capital N is the population. What must be the sample size? I must decide. N is the population. All the manufactured product available in the next room, or all the people coming and sitting for COVID test. Small n is the sample size. I wish to find out the sample size for estimating proportion. This is based on confidence interval. So I'm bringing to you a concept where I'm trying to decide the sample size for two specific purposes. One is to estimate a proportion. This logic is based on what is called confidence interval. Second is to for comparison of two proportions or means, anything. This is based on test of hypothesis. Friends of statistics, I wish to share with you that statistical inference is the life of the whole statistics we are studying. It contains two parts. One is estimation, another is testing. Estimation deals with giving a value for the unknown parameter. So you give two types of estimate. One is a point estimate, another is an interval estimate. If you say the answer is a single value, we call it as a point estimate. If you ask me how many people will recover from hospital in a day, if you give an answer, that's a single answer, but it will be changing because day to day. So better give an interval. That's called an interval estimate. That is the reason why you see when a helicopter is to be landed, a point would be enough, but they will arrange a confidence interval because while coming from there, there could be natural errors of identifying the point. Therefore, a cushion will be given. Just like we expect a comfort zone while traveling in a bus, we want a free zone, big seat, comfort. So this is what is called confidence interval. That is the logic. I don't go to the mathematics or statistics of that one. Confidence interval based, how much confidence you have, how much confidence you wish to have in your estimate. Somebody will ask, what will be the blood loss during surgery? How many ml will go? When this method is used, other method is used. Blood loss must be told in terms of milliliters, plus or minus 5 milliliters or 2 milliliters. That is called confidence interval. The other way will be test of hypothesis. Yes, I have method 1, I have method 2. I believe that method 2 is better than method 1. And my claim, which I wish to verify, is there will be at least 20% improvement. Oh my goodness, I have taken back to my Neyman-Pearson lemma, where the null hypothesis is there is no difference. The alternative hypothesis says that, yes, I have 20% improvement. So these two principles take you to sample size determination. And for finite samples, all these methods are based on infinite samples, and there is a correction formula, which we will come to this later. It is known as a Cochrane's formula. This is a base for that one. My interest is to take you to what is called state-of-art technologies rather than theory, but it is unavoidable. So how do you estimate P? This P is based on what is called margin of error. I will take you to what's called, this is the confidence interval. If P dash is the sample mean, a sample prevalence, this is the confidence interval. I will be working out with this gap. This quantity Z into 1, this is called margin of error. I want to put it less than or equal to D, say 5%. Yes, I want only margin of error, not more than 5%. This is what the doctor says. Please give me an estimate which is having 5% error. Why don't you want a 1% error? Yes. Don't want more than 1% error. Yes. Or I want an estimate which have around 10%, less than 10% error, not more than 10%. There is a secret in this one. The more the error you allow, the less sample is enough. The less the margin of error you impose, I say that you need a bigger sample. Otherwise, you don't get the result based on this formula. So with a little bit of mathematics, you solve the equation Z into something is equal to D. This gives you N is equal to Z square alpha P dash into 1 minus P by D square. Z square, Z is the standard normal deviate, which is usually 1.96. At alpha is 0.05. And as you all know, alpha by 2 is the same as 1 minus alpha by 2 due to symmetry of normal distribution. Kindly remember that the practitioner doesn't know all these things. If some of the statisticians are sitting, you may probably appreciate this one, but for the other man's desk, this is not correct. But in order to work out this formula, I want to solve for N. I know what is Z because you told your fixed alpha is not 5. I also fixed D is equal to say 5% error, but you are demanding something, some knowledge about this P dash. What is this P dash? This P dash is your anticipated value of the proportion, anticipated proportion. Sir, how much you think the disease is present in what percentage of people? You must ask the client. If you say, sir, I think there will be 5% prevalence, 1% prevalence, that is your initial value. That must be substituted. If he says that I don't have any idea, I don't know anything about this PDAC, this is totally a new case, then the only way is don't use this formula. You can't use it. But do a pilot study. You go into the market, do a study, get me trial value, that PDAC. Or second thing is ask an expert like Tirupati Rao. What is the, he says, yes, from the previous studies, I have got P is equal to 0 point something. So this is a luck where your statistician is unable to help the client unless the client comes forward telling something. See how beautifully these formulas have been packed up. Similarly, in the case of mean, I don't go to the details, this will be the formula. This formula requires a still tough element called standard deviation. You ask the doctor, sir, what is the standard deviation? Standard deviation, I don't know. Okay, one is do a pilot study. Second one is go to the previous literature. See, in a similar study, they found standard deviation is equal to 1.2 milliliters. Oh, I will try to use it. That is the method by which this formula can be utilized. But you see, in my prevalence case, as my initial value of P, randomly if I take like that, at 5% level of error, sample size increasing, reaches a maximum at 385 and then comes down. This is a, fingertip formula. If you wish 5% margin of error and you don't have any knowledge, if you take the initial prevalence is 50%. 50% means a person may or may not have corona. It is a bad estimate. I don't know means 0.5. Then you need 385. 385 persons are required if you believe you don't have any knowledge on this one. But as you gain knowledge, your value will be coming down. Yes, I know 75% people will have. Okay, then do only 289. So knowledge helps you reducing the sample size. Interestingly, if you say that I want a very I'm sorry, I made it a, not this is 1%, there's a typing error, this is 10%, 0.1 actually. Then the sample size is very less. If I want 3%, the sample size was, sorry, 3%, yeah, this is 1025. 3%, 5%, it was a mistake, it should have been 10%. With the 10%, what happens is a rough estimate is okay. So instead of 385, I will do only 97. They exhibit an interesting pattern. You see, this is the graph with 3%. This is with 5%. This is with 1%. So one must be careful in telling, just don't arbitrarily say you want 1% margin or 2. Go to the literature, see the objective, see the ethics, see how much error you need, then we can go for it. This is an example which I gave. I will later put it in a different platform. Or this is the problem where you want to identify what percentage of people will have a disease called delirium. The previous study says that it can be something like 6 to 8%. That is how they say. So we started working out with 8% maximum. There, if you work out, taking P is equal to 0.8% means 0.08. D is equal to this one, 5%. The formula gives you 114. On seeing this number, the user may say, sir, it is difficult for us to go for 114, please reduce it. How? Your present margin of error is 5%. I wish to allow 10%, sir. Okay, you allow 10%, you come down to 29. So we must be very careful. Where is 114? Where is 29? So it is not a laboratory experiment, it's a practical experiment where we must tell people how much D must be there. So it's a very sensitive formula. Similarly, in the case of mean, we'll get these things. I will just take you very quickly to this. The users of this PPT later can utilize this. Somebody came forward in the recent years to the rescue of users and created an interesting, a platform in Excel where you can utilize. There are several formula sets here. Each is having like this. For example, this is how to estimate sample size for proportion. It asks all these things. It's a one sample. What is the level of significance? Means level of confidence 95. And how much margin you allow. It says 0.01. I will make it as 0.05. Then by entering, my sample size came down to 73. They use what is called attrition. Attrition means 10% or 5% add to cover possible loss of data, if missing data. So that then in 73 is what is now you round it to 77. This is a very elementary software which works with basic formula. We'll come to other things later. Similarly, in comparative studies, I have two groups. I'm constrained to cut down on this topic because the formula comes, that is what we see. For the first group, we call this as a two-arm study, two-arm. This is my right arm and left arm. Arm means one group. When patients come with the two type of medicines to be compared, in this group you give A, in this group you give B in a random manner. I wish to know what is the proportion of a rash on the skin. Is the rash coming, rash not coming? How many people? P1 in the first medicine, P2 in the other medicine. This is what we wanted to examine. So my interest is whether the difference is significant or not. This difference is called effect. If you don't know any idea about this effect, this method will not work. With prior knowledge on P1, P2 and alpha, we get sample size N1 is this formula, Z alpha plus Z beta also P into 1, something, where P is equal to this one. We don't go to the derivation of all these things here. So in this study, we'll be interested in comparing means, their proportions. Here it is means. I also wish to compare what is the blood loss in a laparoscopy surgery and in a conventional surgery. What is the loss of impression on an ordinary printer and another printer, ordinary toner and an improved toner. So in this case, we'll work out like this. This is the size of the sample. We have a formula. We always decide the sample size for one group. The second group will be, size will be K times N1. That K is called a factor, sometimes a constant. Usually K is taken as 1, but it is not a rule. We can take more. We'll come to this element called delta bias. These are all difficulties. The real practitioner will not be in a position to tell what exactly that delta bias is. What is delta? Expected difference. What is yes? Standard deviation of the difference. Maybe expected difference they may be able to tell, but standard deviation, it is a complicated calculation from previous studies. So there was a contribution by a gentleman called Cohen, who made an interesting study on psychology. He characterized this delta bias. This is called standardized effect, and that helps a lot. This form, we will come to this Cohen's method in a different framework now. He says that you don't ask for mean, standard deviation, all these things. You ask the client whether you believe there is a low effect between these two, moderate effect or a high effect. If it is a low effect, you put D is equal to 0.2 and work out with the formula. This delta bias you write as a D. If it is high effect, 0.8. We shall see how interesting they will come. And these formulas, any of these methods, these are the two formulas on which I concentrated. This is known as, all the methods are based on what's called simple random sampling. You should excuse me. And in real problems, simple random sampling may not work at all. There will be heterogeneity among the members being selected. In medicine, what they do is, they filter out using what is called inclusive and exclusive criteria. People with high BP don't take, even though it is a sample, you ask him, no sir, thank you, you go. So you try to make it as homogeneous as possible, but it won't work when you go to a market, when you go to a mall, when you go to a public community. Then there may be cluster sampling required, there may be stratified sampling required, there may be systematic sampling better, and all these formulas will not help. In such cases, we do what is known as a design effect. This is called, which instead of using a stratified sampling, if you are using simple random sampling, what is the ratio of the variance of stratified to the variance of simple random sampling, or the other way? That factor is called K, and people are expected to supply this information to do what is called adjustment. We are coming to the end of this job slowly with more technologies. This is Professor Jacob Cohen. Cohen made a lot of contributions during his period up to 98. He characterized the quantity delta by saying that it is called effect size. If you are making a comparative study, ask the marketing specialist, do you think that this face cream will have a major improvement or moderate improvement or low improvement? If it is low improvement, this formula can be used with D equal to 0.2, otherwise 0.5, otherwise 0.8. Still, there is some what is called leverage. Don't go be exactly be 0.5 for medium. It can be 0.4 or it can be 0.5. You try and then fix the sample size. How interesting it is. This is the article which one may have to read sometime. You see how beautifully it is. For comparing two means, this is called effect size. Mean of A minus mean of B by sigma. And he says that small effect has 0.2, moderate has 0.5, large has 0.8. This is Cohen's study. We call it as Cohen's model. And he also characterized low, moderate, and high effects for various types of application. If you want to use a association based on chi-square, this is what you can do. Because in a chi-square, there are no parameters. You can't ask for mean or you can't ask for standard deviation. It's a distribution fee method. So he says that depending upon the degrees of freedom we have, 6, up to 6 he wrote. Beyond 6, the same thing will go. He says that if you want to characterize association study with a low effect, then this is moderate and large. It's a small effect, you need 1,362 cases. Probably after listening to this lecture, I will also participate with people. One have to identify the situations where we missed making a calculation for sample size. We'll quickly go to this one. But all these things is a headache. I pray God that there must be a calculator to do all these things. I will take you to this power and sample size calculation, or I will take, power and sample size. Would you admit me another 5 minutes, organizers? Dr. Sridhar, another 5 minutes?
Yes, sir.
Yes.
Continue, sir. Continue.
Yeah, because
no
this is an important one. Yeah. See,
no
I'm
problem,
going to this power and sample size calculator. And in fact, this is a bigger statistics process than any of us. It tells you what you need in a more practical way rather than theorems. What is your sample problem? I am interested in making a 2-sample comparison of equalities. Let us say 2-sample comparison for means. Yes, I got this. This is sample size calculator. You want a sample size calculator? Yes, you are doing like this. It is already there. I could come down to this. Yeah, you can virtually work out. You tell me what is the true mean you believe. Say true mean could be 2, but actually this is for true mean means null hypothesis. Under alternative hypothesis, I will put in our normal terms. What is the null hypothesis mean for one sample? I believe that it is 1.5. What is your true mean under alternative hypothesis? Then standard deviation is 1 to calculate. Please remember that 80% power is this. 1 minus beta is called power. Beta is called type 2 risk. 1 minus beta is called power. We fix power as 80%. It's the convention. If I ask to calculate, my sample size come to 32 because already done. Suppose my difference is 9. Null hypothesis is 1.5, but I believe that new thing is 9. 1 is enough because there is a big difference. It is something like you lost your ball pen in a cinema hall. You need a very big survey to get that ball pen, but you lost your ball pen in your shirt somewhere in one of the 2 shirts. Easy to search. So if the difference is less, If the difference is less, you need a big sample. Suppose the difference is, I will make it as say 0.6. Calculate. You need 10 because I am keeping standard deviation like that. So we can work out based on this method for various things on this. So this is one calculator that helps us in calculating this. Not only this, we shall see shortly. Am I running somewhere? Let's see. Yeah, I am coming to this. Am I missing the sharing screen?
Not visible, sir.
1 minute. I am only visible now, not that.
Sir,